So today we're graphing absolute value functions. That's it. That's the goal. Might want to copy this down here real quick. I'll pause for you. All right, so since Xana brought that up, what we did on the 3.1 homework, I gave you guys this thing, right? And you guys graphed it, and you should have gotten that. Now we talked about transformations last class. What would this do to the graph? Good, nice job. You did your homework. And what would this one do? You didn't? Wow, good memory.
I did 3.1 though.
All right. What would the K do then? No.
Oh no. Yeah.
Vertical, so we move it up or down, right?
Wait,
So
what about negative 8? Was that supposed to go down?
nope. No. If this one was negative, it would go down. So this is up, and this is right. What does this do? It'll either be a stretch or a compression, depending on how big the A is. It will also flip it if it's negative, right?
You know on the negative H, I knew it with the plus K. I said the wrong thing, but I knew what you were intending. But the A, I didn't catch it.
Sure, Elijah. Sure.
Swear.
I'm just teasing you. Yeah. All right. So let's come back to this. I drew this and I erased it. So let me put it back. You guys know what a vertex is, right? It's the pointy part on this graph, the sharp corner. You guys, this is the vertex, right? So what are the coordinates for the vertex? 0, 0. So if I move it to the right H and up K, what will my vertex be now? HK, right? So here's what I want you guys to take away from this, and this is what I'd like you guys to write now. Those numbers make your vertex. Oh, that's my K. I tried. But there we go. So that's what I'd like you guys to write there, though. Is the vertex is HK. Now I want you guys to notice something. This is a subtle detail, easily overlooked. You guys ready? That's a minus sign, right? What's that? It's a positive. So no matter what the H is, you're always going to change its sign. Okay? Did I do that to the K? No. Remember how we talked about with the horizontal transformations? They always do the opposite of what you think. Well, a negative H moves it to the right. Therefore, your H actually is a positive. Likewise, if you had a positive H here, it would move it to the left, and your vertex X value would end up being negative. So you're always going to change the sign of the H, but not the K. Okay? Now, since these graphs are pretty much like linear functions, they're just straight lines, except for at one point they switch, right? You have a straight line connected with another straight line. This here, it's going to do the same thing it did when you had this, only if I write it like this, it might look more familiar. The A is playing the role of the slope here. So it's going to be basically your slope. Let me clean up my slide. It's a little messy.
I'm sorry.
Yes, I'm going to explain it right now. So write this down. So the A plays the role of the slope. What do you guys notice that's interesting about the run, though?
It's inside the.
I've got little arrows next to it, right? Now, when we did straight lines, it was rise and run, right? But with absolute value functions, you're going to start from your vertex is where you're going to start from. You're going to rise, but you're going to run in two different directions. That way you get that V shape, okay? So that's the only difference. You're still going to do the rise and run deal. It's just that since absolute values are the same on the left and right, when you rise, you run both ways, and that's what gives you that V shape, okay?
Are we going to do it with numbers?
Yeah. So there you guys go. That's that. Sure you guys have probably done this before in other classes, but if not, this is your chance to get it or review. So let's go ahead and do some problems here. And write down number 1. I don't know if we really need this many examples, but we'll find out. Maybe we do.
No, there's a problem on 3.1 where you didn't explain the division, where it had, but like I figured it out. It was kind of easy, but it had like 9 plus 5, and then it had the absolute value of x minus something, and then plus 1 equals to like 58 or something.
I'd have to see it. I can't visualize. That's too much information for my puny brain to see. So I could look at it with you later if you want to show it to me. Let's see. All right. So step 1. Vertex. All right. So we talked about how this number here and this number here give you your vertex, but what do we have to do to this?
You gotta flip.
You got to change that sign. So it's going to go from a -3 to a +3. Do we change the k value?
No.
No, that stays the same. So my vertex is going to be over 3 and up 1. 1, 2, 3, up 1. Now we get to do our slope, so I'm going to add a few more lines here just so I can do my slope. All right, now my slope is 2/3, right? So I'm going to rise 2, and I'm going to run 3, but when I run 3, I'm going to go both ways. So rise 2, run 3, starting from your vertex. Okay, ready? So rise 2, run 3. Rise 2, run 3. Put a dot at each one of those ends. So up 2, over 3, up 2, over 3. You don't have to draw those dotted lines. I'm just demonstrating the slope. Those aren't actually part of the graph. All you really need are these 3 dots, and once you have those 3 dots, you just go ahead and connect them, and that's what that absolute value graph would come out to look like.
If we're ever writing the slope, do you write the arrows, or do you just put like positive or negative?
Writing the slope, do we ever put the arrows?
So yeah, when you
Oh,
if
like,
you were to like
would-
say
it would-
slope is 2/3, would you
Like that?
would you draw the lines, or would you do like plus or minus, or would you kind of just?
Are you talking about, so like, what you don't have to do any of that, because this I'm just doing for your notes.
Oh,
All
okay.
I need is the graph. So this is just me trying to like explain what I'm doing as I
Oh.
graph. But yeah, you don't have to write all that.
Okay.
I mean, maybe it'd be nice to have in your notes, but when you do your homework, you don't need to write step 1, step 2. It's not necessary. All right, let's go ahead and take a look at number 2 here. But yeah, I get what you mean by the plus or minus. That might work. Let's go ahead and write down number 2. Okay, so I'm gonna let you guys go ahead and take a guesstimate. I'll give you like 10 seconds. See if you can figure out what your vertex is. I'm not calling you. If you want to check with a neighbor, you're welcome to. You've got 10 seconds. Give me a vertex. All right. I'm going to be asking Kalani, what's our vertex on this thing? That's right. -1 and -3. So we're going to go left 1, down 3 for our vertex. And we're going to add a few more lines on our graph because we're about ready to do slope, and we'll need some more lines for that. Okay, now my slope is -2, and if you want, you can think of that as -2/1. Now, the top then when the top's negative, that means we go down, right? And the bottom, we always go both directions. So this time we're going to go down 2, left and right 1 from the vertex, okay? So here you go. Down 2, left and right 1. Now, as you guys can see, this graph even makes sense from our transformations yesterday. We know that the regular absolute value function, just y equals this, absolute value of x equals, looks like that, right? But this one's the same thing. It's just that it's been shifted to the left 1, shifted down 3. It's been stretched a little bit, but it's been flipped upside down, right? So left, down, flip.
Can you show me how to graph -2/1? Like, how did you graph 1 twice? Like,
So, how shall we do it?
Oh,
How?
I think she's saying, you know, how do you go both ways?
yeah, I don't get it.
So maybe if I just write the numbers on there instead. So what I do is you start here, right, with your vertex. So you're going to go down 2 because it's -2, right? And then with absolute values, you go both ways. Like Nick was saying, left 1, right 1. You do both. So with regular lines, it's just rise and run one direction. But with absolute values, it goes both ways. So you need to go both ways when you do your slope. Okay. All right. So let's go ahead and write down number 3.
Is this all going to be in the
Is this all that's gonna be in the homework?
Yeah, or am I going to have to ask about myself?
I don't know. It should be.
Because I'm going to see a problem. It's going to have like the absolute value on each side of the list.
I can tell you, I always try to make sure that your homework matches what we learned, but sometimes I do throw thinking questions in there. But those ones I don't care too much about, so long as you try.
You're going to throw one that has a lot of work in it with just the no solution. So I can't figure it out.
Evil math teachers. We're always plotting.
What's wrong with you?
Write down number 3. Write down number 3. All right, so number 3, we're missing some numbers, right? Same rules apply to absolute values as did linear functions, okay? So let's write a note up here, missing numbers. So what happens if you're missing your slope? What was that on linear functions when we didn't have a slope? It was 1. So if you don't have a slope explicitly written, it's 1. Now, what happens if we're missing h or k? Those will be 0. So if you're missing either the h or the k, those would be 0. But if you're missing the slope, that's 1. We talked about why that is back in linear functions, because the slope is something that's multiplying. You don't need to write 1 if you're multiplying by 1, right? So why bother writing it? So if it's not there, it's a 1. The h and the k are numbers that are being added. So if you're adding a 0, there's no point in writing it, right?
I'm sorry,
So
what is that? The second one is missing pork.
it says missing hark. No, it says missing h or k. Yeah. If you're missing h or k, then whichever one's missing, those would be 0. So let's go ahead and take a look at this here. What am I missing? My slope? Yes. What else am I missing? We're missing the h, the number that's being added or subtracted. So you don't have to rewrite this. I don't. But if it helps, and I think for your notes it might be helpful if you fill in the missing numbers. So since we're missing our slope, it's 1. And since we're missing the h, it's 0. So now we can see that our vertex would be 0, -2, good. And my slope is 1. So that means I'm going to go over 1, up 1 to the right, over 1, up 1 to the left.
So 1 over 1.
Yep. Oh, poop. All right, go and write down number 4 and see if you can predict what the missing numbers are. I shall pause. That's how we deal with missing numbers. So my vertex would be 2, 0, right? My slope is -1. So that means I go which way? Down 1, left and right 1. So down and left and right 1. We're going to practice in a minute. You can work out the kinks. Work out the kinks.
So is the K always?
If it's not
the
there.
right, I'm sorry. Is the K always going to be at the right?
That's a great question. So Elijah asked a really good question. I want you guys to hear what he said. So how are you going to know? I could write it like this. Okay, this is definitely the what? That's the H, right? Because it's the 1 in parentheses. What's the number that's multiplying the X in the front? That has to be the A. So that's actually a -A. That guy right there is your K. So you could have them written funny like that. No. Because you'd be violating the laws of mathematics.
So number 2 is A. Is A on the left and K on the right. Number 2 on the -2 is A, and then -3 is K.
Yeah. So this is A, and this is K.
Oh, that's what was in 3.1.
So now to answer Melanie's question, because this is actually a really common mistake, she asked, can't we just subtract those and get 4? No, you can't do that. Now, the reason why you can't do that is because this 2 is being multiplied with something, right? So instead of having some big ugly thing that makes things look confusing, let's just replace it with something simple, okay? Let's just say that this is y. Now you tell me, why can't I subtract those? Maybe. I'm looking for a keyword. Why can't I subtract these? They're not like terms. So that's why. It just doesn't look like a like term situation, but it is. So that's why you can't combine those. That's actually a really common mistake, so I'm glad you brought that up, and I thank you for bringing up the issue about the K being different. Dang it, I was going to sneak that K in the front on your homework. Now I've taught you. Dang it!
Honestly, like
I'll get you, Elijah, trying to foil my evil math teacher plans.
That was the only 2 minutes you're going to ever see this morning. But
Don't talk bad of yourself, my friend. You persevere, and I think that quality is better than many other qualities, even intelligence. Too good. All right. Let's do another one. Write down, you might want to write down your title, because that's kind of the point of this slide. And then write down number 1. All right, guys. So, we saw this last time, didn't we? What did we do about that last time? We're going to have to factor it out. Because here's the thing. This B is affecting what this H looks like. It's obscuring it. It's not really what it's truly supposed to be. The B is affecting that. So we need to remove the B from the situation. So 3, 2x minus 1. I'm going to show you. We're going to factor it out, just like we did. Is this correct, you guys?
yeah.
And then what's this guy?
+1.
+1? All right, thank you. All right, so what we're going to do is same thing we did last time.
I mean -6. I'm sorry.
Is it -1?
-6.
Oh. Is it minus? Speak now or forever hold your peace. Okay. All right. So what I'm going to do is I'm going to factor out the number in the front. That's a 2, right? So if I divide both of those by 2, what do I have left inside?
4x minus 12. My bad. Minus x minus 12. 3.
There we go. You're thinking good. That'll help you with the fraction ones in a minute. Okay. Now, little property of absolute values. Anytime you have two pieces of an absolute value being multiplied together, you can separate those into two separate absolute values. Okay. Now you don't have to show all this work in the future, but I'm just showing you the math behind it. So notice how I separated the 2 and I put it in its own little absolute value bars. That's a math rule. You can do that. You can break absolute values up like that if they're connected by multiplication, not by addition. Okay. It's just the easier way. I'll show you in a second. And what is the absolute value of 2? It's just 2, right? And what's 3 times 2? Okay, so from now on, now that I've explained the math behind it, I'm not going to really do all that in the future. After I take this out, you guys, I'm just going to multiply it by the number in the front. But you have to remember, if it's a negative, it's going to end up positive because the absolute value kills the negative, right?
Is that our final?
Well, that's the result, and then we would graph it. I think we could skip the graphing if you guys, do you guys want to practice more graphing?
Yes.
We'll give you a chance to practice somewhere in a minute. Let's go ahead and take a look at number 2. So from now on, I'm going to skip all of these steps here. I'm going to write down the problem, then I'm going to factor out the number, but from there I'm just going to jump straight down to here by taking that number's absolute value and multiplying it. I'm just going to do that mentally, okay? But if you want to write the whole thing, you can, okay? All right, look at smiling, Amber. I'm feeling judged. I'm feeling judged. You were? You're a copycat, bro. All right, okay. Let's go ahead and write down number 3, please. I'm going to skip 2 for now.
You're skipping 2 because I'm going to be on
Yeah. Shh. Write down number 3, please. We're supposed to, just so you guys know, we are supposed to be graphing, but I don't want to drag it out too long and cause anybody to lose consciousness. Okay. So, who's ready? So we have y.
Absolute value negative 2x minus 4.
That's it?
And then there's nothing on the right, so it's plus 0.
Okay, you can put the plus 0. That's fine. I'm going to not right now, but you can. That would be perfectly fine. So like if you were graphing, it would be helpful. All right, so the first thing I'm going to do then is I'm going to factor something out. What am I going to factor out? What kind of 2 am I going to factor? I'm going to take out the negative 2. Okay? And so if I did that, what's going to be left on the inside? See how the signs change? Because we're dividing out a negative. So if you divide this by negative 2, you're just left with x. If you divide that by negative 2, you get a positive 2. Okay. So what's the absolute value of negative 2? You're too far ahead of me. What's the absolute value of negative 2? Just 2, right? So I'm going to multiply 2 here to the top. What's that going to give me? 4 over 3. That's it.
I'll test it. Actually, put it inside the parentheses when you mark this.
In the parentheses?
Yeah, the negative 2 on accident.
What do you mean in the parentheses?
Like, because I did on accident. Because I put parentheses on the negative outside the negative 2.
Like this?
Yeah.
But did you still have your bars?
Yeah.
That's fine. That doesn't matter. Yeah. Okay. So there's that. Let's do one more. Fractions. Go ahead and write down number 2. Hey. Oh, you already have it? I'm going to wait. I want to give most people are going to need a little bit of explanation, but I'll let you give us our final answer there. All right, so we have 2, 1/3 x minus 1 equals 1. So I'm going to let Conacher tell us what he thinks the answer is first. What do you think the answer is, Conacher? Conacher? What did you get?
Vertex is 3 and minus 1.
Oh, just what's the equation going to be?
Oh. 2 by 3 absolute value x minus 3 minus 1.
Minus 3 minus 1. So he's right. Now let's see how he got that, okay? So I just wanted to give him a chance to answer that because he had it. Now, all right. This don't write this, just watch. This is the same thing as what? 2 divided by 1/3 is the same as 2 times 3. Same change flip? Don't worry about that right now. Do you agree?
No, I don't.
You guys don't know same change flip? Okay, let's do another. You guys don't remember how to divide fractions?
Nope. Oh, I don't. Sorry.
That's okay. Let's do another one. How about this? 6 divided by 1/2. So what we do is we same, change, flip. Now if it helps you, I could put that over 1. Okay? You guys remember that rule from division? Okay. That's for double negatives. All right, so does anybody need to see one more example of that before we go any further? Okay, so now I'm going to answer Xana's question. Why are you doing this to us? Okay, because what have I been doing with this number every time? I've been doing what with that number? Factoring it out. And when you factor, what kind of math do? U starts with a D. You're dividing it, right? So check it out. If you're dividing this by 2, what do you get? You divide this by 2, what do you get? You get it 1x. You divide this by 2, what do you get? 4? Come on, guys. What's 6 divided by 2? It's 3. 4. Slappy. You're messing with me. All right. So we're going to do this again. But we're going to be dividing these by what now? 1/3, right? All right. So let's go ahead and do that. Ready? So when you divide by a fraction, though, that's the same thing as doing what? If I do something divided by 1/3, that's the same thing as that something being what? Multiplied by 3. Okay? So let's go ahead and put that to work for us. We have y equals, what was the problem?
2 absolute value 1/3 x
Minus 1?
1.
And that's it? Oh, minus 1. Okay. So here we go. This is the magic. You guys ready? I'm going to put 1/3 out here, and I'm going to divide both of these by 1/3. So if I divide 1/3 by 1/3, what do I get? 1x, right? What do I get if I do 1 divided by 1/3? There you go. Yeah. Same change flip. Sorry. May the force be with you. All right. We're dividing this into these numbers. So 1/3 divided by 1/3 leaves you with 1. And 1 divided by 1/3 leaves you with 3. Why? I showed you the math right here. Same change flip. Okay, so now we take this number out, we multiply it to the front. What's 1/3 times, just a sec, what's 1/3 times 2? You gonna ace this, Amber? Miss cell phone. All right. What up, G?
What about the negative?
What about it?
For what side?
No, just the ones in the parentheses. Just the one in the brackets. I mean, yeah. You guys have a good day. I'll try to. No.